about dilations on the coordinate plane. First, let's review what a dilation is. A dilation uses a scale factor which reduces or enlarges a figure. So if it is a reduction, then our K value is going to be less than 1, but greater than 0 because it's always a positive number. If it's an enlargement, then our K value is going to be greater than 1. So if we look at these examples, if K equals 3, this number is greater than 1, so that means this is an enlargement. And it's saying that you are making the image 3 times bigger than the original. If I look at number 2, K equals 1/3. This means you are taking 1/3 of the size, or you are multiplying the image by 1/3, making it 1/3 smaller. So that is a reduction. For number 3, we have a K value of 5/4. This fraction is greater than 1 because the numerator is larger than the denominator. So this is an enlargement. And the last one, K equals 0.93, which is less than 1. So this is a reduction. Next, we are going to determine what the scale factor is from 2 figures on the coordinate plane. So we start off with looking at figure A, which is the larger triangle. That's your object. And the smaller triangle, B, is going to be the image. So we started with A, we ended at B. I'm going to pick one of the vertices from the large triangle and compare it to the corresponding vertice of the smaller triangle. So let's use this point right here as our comparing factors. When we are comparing, we always compare image divided by object. So I'm going to look at my image first and identify this coordinate point. When I'm identifying a coordinate point, I start at the origin, I'm moving to the right 1, which is a positive 1, down 1, which is a negative 1. So that coordinate is going to be 1, negative 1. I'm going to write that as a fraction for image, 1, negative 1. Then I'm going to look at the corresponding angle for the object, and I'm going to count over from the origin, 1, 2, 3, down 1, 2, 3. So this point was over positive 3, down negative 3. So I'm going to write that in the denominator because that was our object. That was a positive 3. Positive 3 divided by, comma, negative 3. Now our x values are lined up and our y values are lined up, which gives us a ratio, and they should come out to the same ratio. For these 2 triangles, the scale factor is 1/3. The x values have a ratio of 1 divided by 3, and the y coordinates have negative 1 divided by negative 3, which is still 1/3. So this was a reduction with a scale factor of 1/3. Now let's look at the second example. I'm starting at the smaller triangle, A, and I'm going to go to the bigger triangle, B. Since we started small and got big, that means it's an enlargement. So I'm looking for a number that is greater than 1. I'm going to pick one of the vertices from each object, each of the pictures, and find its corresponding parts. Again, I'm looking for image over object. My image is the after picture, so that's B. I'm going to select this point right here on the corner for my image. So that point on the corner, I'm going to go over 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5. So this point is 5, 5. And then I'm going to find the corresponding part for the object, which is over 1, 2, up 1, 2. So this point is 2, 2. As I'm writing this as a ratio, I'm lining up my x's, I'm lining up my y's, and you should see that we're getting the same ratio for both the x and the y, so that tells me what my k factor is. I cannot simplify 5 over 2, so I'm just going to leave that as my scale factor. You could change that to a decimal, which would be 2.5, which still tells you that it is an enlargement. Now we're going to go down to another example. What if they give us just the 2 points and you have to find the scale factor? So in this case, it tells you that R is the image. R is the image. So I'm going to put an I over the R point, and I'm going to put an O over the A. So that tells me my image and my object. We write the ratio image over object. So I have 9, 12. Is my image, and 3, 4 is my object. Now I can find my ratios for the x, which 9 divided by 3 can simplify to 3, and my ratio 12 divided by 4 simplifies to the k value of 3, because 9 divided by 3 is 3, 12 divided by 4 is 3. I'm going to do the same thing for number 10. I'm going to go ahead and identify my image as my R and my object as my A. Image over object. 6, 8 is the image. 9, 12 is the object. And now I have a ratio of 6 over 9, and I have a ratio of 8 over 12. Both of those simplify to a k value of 2/3. 6 divided by 3, 9 divided by 3. 8 divided by 2, 12. 8 divided by 4, 12 divided by 4. You get the same answer of 2/3. Last one would be if you want to find the new points. In this problem, they gave you the object and they told you the scale factor. So now you have to come up with the image. You're going to do that by taking the point. So if we take A, I'm going to multiply the point by the k value. So 2 times 1 is 2. 2 times 1 is 2. So my new point is 2, 2. If I take the B point, I'm going to take that and multiply it by 2 as well. So that point was 3, 1. So I'm going to multiply 2 times 3 to get 6, 2 times 1 to get 2. So these are my 2 new image points. I'm going to jump over here to number 13. And this time it's a little trickier because we have a k value of a 3/4. So I'm going to start with my A, and I'm going to multiply my A point times 3/4. So my A point was 4, 4. I'm going to multiply 3/4 times 4, and that's going to give me a 3. You can put that in your calculator. You can say 3 times 4 is 12. 12 divided by 4 is 3. Same thing here. 3 times 4 is 12. 12 divided by 4 is 3. And then I have my B point. Multiply by 3/4. 8, 12. I'm going to multiply 3 times 8, which is 24, divided by 4 is 6. 3 times 12 is 36, divided by 4 is 9. And that is my new image points. They're called A prime and B prime.